In today's video, we're going to be demonstrating how to set up a usable or quote usable cluster on a group of Raspberry Pis using Docker and Docker Swarm. The reason for this is there's many videos on YouTube, but all of the videos, or a majority of the videos rather, because there are some that don't, use something called MPI. And MPI is a great tool for making a cluster easily, but the problem with MPI is it's really meant for using custom scripts and custom software you wrote. And as a lot of us home lab users or creators are doing a lot of work that's more application based and with software that's written by other people, MPI is cool, but it really doesn't offer a lot of workload. And I want my cluster to be able to sit on my mantelpiece and be a conversationalist. Well, when my friends come over or my wife's friends come over and they ask why there's these blinking lights on my mantle, well, I don't want to have to tell them it's something as lame as scraping all the tide data for the entire East Coast and compiling it into an Excel spreadsheet. Even though that might be cool and that might be my interest, a lot of people go, why? So with that, we're going to create this usable cluster with something called Docker Swarm. Why Docker Swarm versus something like K3s or full-blown Kubernetes? Well, the simple answer is I had a bunch of old Raspberry Pi 3s laying around as the world has moved on to Raspberry Pi 4s and even Raspberry Pi 5s now, and the 3s have a lot less use in most people's life. And I wanted to see if I could make something that was still cool and usable. I have for many years dreamed about having a cluster computer, but as I stated before, really never had a great use for one. So today with Docker Swarm, I'm going to make a cluster computer that I'm able to use in my home lab for home lab type projects. So I hope you enjoy this presentation where I take you through setting up your own Docker Swarm cluster on a group of Raspberry Pi 3s. So the first thing we're going to need to do to start setting up our Docker Swarm on a Raspberry Pi is to create the Raspberry Pi's hard drive per se, but at least the SD card that the Raspberry Pi is going to run off of. In order to do that, we're going to use the Raspberry Pi Imager tool that's shown here. And I've already gone ahead and installed the Raspberry Pi Imager tool from raspberrypi.com/software. And due to the fact that the installation is different from operating system to operating system, I'm not going to show you the installation process. I'm going to start off this tutorial showing you how to actually make that SD card and the settings that we're going to configure in the creation of that SD card. So here's an enlarged version of the Raspberry Pi Imager tool, and during the enlargement process, unfortunately, my cursor disappears. So you'll have to kind of pay attention to the different shadings from the box where we're clicking and listen to what I'm having to say. So the first thing we need to do here in this newest version of the Raspberry Pi Imager tool, and again, we're using version 1.8.1 here for this tutorial, is to select the Raspberry Pi device that you wish to use. And for this tutorial, we're using some old Raspberry Pi 3s that I had laying around, so that's what we're going to select here. And you can see at this point of making this video that the 5's already out, and we still have 4. Unfortunately, due to this chip shortage and the relative size of my channel, I'm unable to have 5s, and my 4s are kind of precious to me for doing other things. So we're using the 3, which I have quite a few of at this point. Now we need to select the operating system, and we're going to do that by clicking Choose OS, and we're going to get this window here. Now we can choose the legacy operating system by default, and we're going to have to use a legacy version here for the Raspberry Pi 3, but I want to use the 64-bit Lite version. So in order to find that, we're going to click Raspberry Pi OS Other, and then we're going to scroll down and notice they're all labeled legacy. And we have legacy light, legacy full, legacy 64-bit, but I want the legacy 64-bit light right here, so I'm going to select that. Now we select the storage drive, and you can see I'm using a 15.5 gig SD card right here, so we're going to select that. Now, before we used to select a little gear icon in the lower right-hand side of this screen, that's gone, and it's been replaced by a next button. So we're going to hit next, and we're going to get a window that looks like this. Here at this window, we're going to click Edit Settings, and we're going to need to fill in various information at this OS customization screen. This is going to make the overall headless installation of Raspberry Pi OS much easier for us. So we are able to customize our host name, and you can see I'm calling mine K3S Node 2, and I know this is a Docker Swarm video and not a Kubernetes video, but this is what I'm calling it, and it's kind of just a leftover naming convention from a former project that I'm utilizing here at a moment. You may see this name change throughout the rest of this video, as different parts of this video are going to be filmed at different times, and I may use a different naming convention for the rest of this video. We'll see what I do at that point. You can see that I've also filled out username and password, and it's very important that you don't use the default passwords at this day and age for the Raspberry Pi, so we are definitely filling that out. Now I have some wireless information filmed out, and that's right, I'm using wireless, and it's just due to the availability of gear here at the Golf House and what's easiest for me to do at this moment in time. However, I do not recommend that you use wireless for a long-term production environment. If you're kind of home labbing and playing around with this and it's not going to even run vital functions inside your house, Wi-Fi is fine to use. And of course, I've had to fill out that country code. The Raspberry Pi doesn't like to use wireless unless you have the right country code filled out. And I've also selected the time zone so that my time in my device is correctly updated from the NPT server, wherever that is. Now, moving on to services, I've enabled SSH, and I chose to enable an SSH key. Now, my key has already been created and automatically filled in. If you don't have a key here and you wish to use it, you can hit the run SSH keygen command, and everything will happen automatically for you, including filling in this key box. Now, this is a more secure and easier way to SSH into a device, and if this device is ever going to see the internet or long-term use, I highly suggest that you use an RSA SSH key. It makes things a little bit more secure, and it also eliminates some of the hassle for you, as you don't need to use a password for your user account when logging in. The last setting is going to be options, and there's really nothing too special here about the opt-ins. I have all three of the default boxes checked, so that's what I'm going to use. Now that all that's filled out, we're just going to go ahead and hit save. And we automatically come back to the main screen of the Raspberry Pi Imager tool. And at this screen, we're going to select yes, because we want to use our new OS customization settings that we just configured. And yes, we understand that we're going to erase this entire SD card, so we're again going to press yes. The installation process is going to continue. And as you can see from that kind of background pop-up popped up here on a Mac, I'm going to have to enter my system password in order to give it permission to begin writing to this SD card. And now the process of writing this installation to this SD card is going to begin. When this all finishes, this program will automatically eject our SD card so that we can move on with the rest of the steps of setting up this Docker Swarm. And note, you are going to have to create some other SD cards with different host names for this installation. If you're using a 3-node system, which is the minimum that's suggested for high availability, you're going to need a master and 2 other nodes. If you're just looking to play around and you have 1 or 2, well, really 2, because you can't create a cluster with just 1, you can go ahead and just title it differently. So I'm going to leave you to make your 2 other cards, and I will be back with you when we begin configuring our master node as well as our worker nodes. Okay, so we're here and we're going to configure our second worker node in this video. Now, the first worker node is going to be configured the same way as the second, but I didn't film the process of configuring the first worker node. So with that, the first thing we're going to need to do is get an open terminal window. And you can see that I have the two other terminal windows connected to the master and the node up here on my screen. Now that's not important, but that's how I like to work, so that's what I'm going to do. So the first thing I want to do here is blow up this particular terminal window for you so you can see what I'm doing. And we just inserted the SD card after flashing it into this particular Raspberry Pi, and we powered it on. So the first thing I need to do is establish that SSH connection. And I'm going to do that with the host name itself. So SSH username at host name. But a lot of networks won't automatically recognize the host name, so you may have to find the actual IP address for your particular device. And instead of using the host name, use the IP address. So it would be something like 192.168.1 whatever is assigned to it from the DHCP server. But in my case, my network is configured to use host names, so it makes it a little easier for me. So now that we have an SSH connection, we can start with the first commands. And of course, this is a fresh SD card, freshly from the Raspberry Pi imaging tool, and this is a legacy operating system at this point as we're working on a Raspberry Pi 3. So as always, we want to go ahead and do an update to this operating system and make sure all the repositories are updated. And especially with this being a legacy operating system at this point, we want to make sure all updates are installed as well. So we're going to use the sudo command so that we are using super user or root permissions in order to have enough privileges for this user account to do these functions. So the first command is going to be sudo and then apt, which is referred to as aptitude. It's a package managing software that comes by default with all Debian-based operating systems that I know of, and Raspberry is just the same as all the rest. So we're going to use apt, and we're using update. Now I'm also applying 2 ampersands, and that's just going to allow me to string the second part of this command, which is again going to be sudo, and then it's apt upgrade -y. And what this command's going to do is install all the updated software from the updated repositories that we're doing with the first half of the command. And usually Debian-based operating systems, or APT, asks you to verify that yes, indeed, you want to do that install. So what the -y is doing is allowing us to tell it in advance that yes, we want to do that upgrade. So at this point, we can press enter, and that command's going to run. And I'll be back with you when we are done doing this update. Okay, so now that our Raspberry Pi has fully been updated, I'm going to execute our curl command that's going to download a script from git.docker.com. And what that script's going to do is install Docker. So all 3 nodes, or all the nodes in your cluster, are going to have Docker installed on them before you can start building your cluster. So curl is the command that I'm going to use to pull down and execute the script. So I need to tell curl that I'm pulling the script down from a website. So I'm going to use the -ssl command. Then I'm going to put the URL for the script, which is https://git.docker.com. Then I'm going to put a pipe delimiter, and I'm going to tell the curl command that it's an sh script, so that as soon as it downloads the script, it's going to execute the script as well. So at this point, now the script has been entered. I'll just hit the return key and we'll run the script, and everything should be automated here for installing Docker onto our system. Okay, so now that Docker's installed, let's go ahead and execute a user mod command that's going to add the group Docker to our user account. And what this is going to do is give us the privileges to run Docker commands without having to have sudo user privileges. So the command sudo user mod -ag or add group Docker with the lowercase d $user. And what the $user does is it automatically brings over our user account from our command so we don't have to enter it. And the last command we're going to issue before we begin actually connecting the cluster and do a system reboot is going to be a command that's going to turn off the swap file here on Raspberry. And the swap file, although it can be used on Raspberry with Docker, it does in fact impact the performance of Docker and make things a little less enjoyable to use, especially here on a low performance system. Now, this swap file won't be turned off fully until we do a reboot, and some of our installed updates also require a reboot to become functional. So let's go ahead and issue a sudo reboot command and go ahead and restart this node in order to continue on with the installation process of our Docker swarm. All right, so at this point in the video, you should have 3 or at least however many nodes or clients that you have in the clusters, SD cards set up, and Docker installed on them. So it's time to start creating the cluster. In order to start creating the cluster, we're going to have to create the master node for the entire cluster. And in order to do this, we are going to go ahead and SSH back into our master node. And here, I'm just going to quickly clear this screen so it's less cluttered for you. And this process of creating the master node is actually quite simple. It's going to involve a few commands though. So the first command that we're going to need to execute is the IPA command. And what IPA is going to do is it's going to display all of the IP addresses configured inside of the system. And you notice we have a few here, especially on a Raspberry Pi, where we have wireless active and an Ethernet port. But we also have the configured Docker network, as well as the loopback. Now, you can notice that I'm actually using wireless here, and although for projects like this it isn't suggested, here at this particular location, it is the ideal solution for me in this scenario. Now, I'm not going to suggest that you use wireless, but know that you can, but you may have either some performance problems or some reliability problems that just generally come along with wireless. Now, depending on your wireless gear and your network configuration, these may be more or less. But what we need to denote from this particular command is this address right here. And since we're using wireless, we're choosing the wireless one, 192.168.3.13. This is going to be the IP address for our master node. Now, the next command we're going to have to pay attention to is going to actually be the command that's going to configure our Docker Swarm master node. And that's this command right here, Docker Swarm init, and then the IP address tag, which is going to let the ipinit script know that we're creating a master node and what the IP address to that master node is. So we can enter that IP address that we found above with the IPA command. And depending on your network configuration, you may know the IP address of your system and may not even have to run IPA. But in my case, I'm using host names and my network's configured to resolve IP addresses from the host names thousands of clients on my network. So I just need to enter a host name for my SSH session. So I didn't know my IP address in advance. Anyways, this is the command, and let's press enter and look at what happens. So it ran fairly quickly, and it also spit out a command here. And we want to take note of this command and copy it, because even once our swarm's up and running, if we choose to add more nodes to it later, we will need this command to do so. So we want to go ahead, save that off into a notepad, put it in a safe place where nobody else will find it, so we can add more nodes later if we want to. But we're also going to need it to add all the workers here today. So what this command does is it joins another worker node to the master and gives them a secure way of communication through this particular token. Notice it also includes the IP address and the port number. Now here in a moment, we will use a similar command to go ahead and join these workers, and I'll show you what that process looks like. Note, it is going to be a similar command because I'm actually filming the creation of the master node after my actual cluster was set up on a different command. The token is going to be a little bit different and the IP address is going to be a little bit different, but that's just due to the nature of how I created this particular video. All the steps will be the same, and as long as you're using the command that was generated by your swarm init, you'll be fine to do so. Okay, at this point, let's look at what's involved with setting up a worker node for a Docker swarm. So what we have here is 3 Raspberry Pis that have had Docker installed and all their updates installed on them. And you should also have already configured one of the Raspberry Pis as a master node. Now it's time to configure your worker node. And we're here on a terminal session, which we're going to log into the second worker node. So this will be a 3-node system, 1 master, 2 nodes that are going to give us an odd number of voting rights for high availability later on. And today we're setting up the simplest form of a cluster. So with this reboot, we were of course logged out of our terminal session, so we're going to hit our up arrow and reestablish our SSH connection, and we're using host names today because my network is configured to resolve them. If your network is not, you can use an IP address like 192.168.1, whatever is assigned to your system by your DHCP server. So now that we have a session established, we're only going to be required to execute one more command in order to set up a swarm or a cluster of Docker systems that are going to be able to work together. So this command is going to be docker swarm join -- token, and then whatever token has been created by the master node for joining it, followed by the IP address for our master node. And if you need the IP address for your master node, you can find that by typing the command IPA on your master node. And unfortunately, I've had little success with using host names to resolve this at this point with this command. So you can see that I have 192.168.3.7, which is the IP address to my master node. And then it's followed by a colon and a 2377. And what 2377 is that's the port identifier for what port Docker Swarm's going to communicate with the master node on. So we can hit enter at this point, and Docker is going to go off, communicate with the master node, and set up a link where the two of them can now communicate with each other. So I did have to end up executing this command a few times. And the actual command for this token is given to you in the installation process. But unfortunately, in the filming of this video, I did things a little bit in reverse. That's why you see us filming the node setup or the worker setup on node 2, because I'd already configured node 1 as kind of a trial process here. So the token was a little bit wrong and we got a few different errors. But as you can see here, when we finally successfully joined the Docker swarm and created the cluster, that it gave us a successful message of this node joined the swarm as a worker. Now, to see this worker and the full configuration of the swarm, we should be able to execute the command docker node ls, which should display all the different nodes connected to this swarm. So let's go ahead and execute that and see what happens. Okay, so here on the master node, now that we have joined a worker node, we should be able to execute the command docker node ls. And that should give us a printout of all the worker nodes and the master node inside of Docker. So basically, it should give us kind of a map per se of all the systems connected to this particular cluster. So in executing that command, we can see the ID of all 3 of the nodes or systems connected to the cluster with an asterisk identifying the master node. And under host names, you can also see the master node named. We can see that under status, they're all ready and they're available for workloads. And under manager status, we can also see the master identified as well as the engine version that they're all running. So at this point, we have successfully created the simplest form of a Docker Swarm cluster computer. And I really consider this, other than maybe an MPI cluster, to be the simplest configuration of a cluster computer that's available for most home enthusiasts. As you know, K3s and K8s or Kubernetes is a much more involved installation process with having to have many different systems configured and different things working together. Now, Kubernetes does have some benefits and of course some drawbacks over a Docker swarm, and in reality has somewhat taken over the industry as the preferred technique for creating a cluster computer for running containerization. But Docker Swarm offers a lot of advantages for us in our home lab learning about containerization and cluster computing with containerization, with one of the strongest being that it will run more efficiently on low-end hardware than K3s. And you can notice from my host names that I actually started this project out with trying to use K3s, and I found that my Raspberry Pi 3s were just a little too low end to do what I wanted in any smooth manner, and I kept having crashes and a lot of system hang time. So I switched over to creating a Docker Swarm, and I hope you enjoyed this video about creating a Docker Swarm and you're able to start experiencing some cluster computing with some of your more low-end hardware here today in 2023 with the Raspberry Pi 5 coming out. The Raspberry Pi 3 has become very obsolescent and a lot of software doesn't run very well in it. But if you're like me, you probably have 3 or 4 kicking around from former projects that have been upgraded and you don't know what to do with them. So they're kind of just wasting up space and you don't want to throw them in the garbage, and good working hardware, still you want to have a use for it. So it'll allow you to learn about a cluster computer and continue more on your journey. So with that, I'm going to conclude today's video. Please pay attention and subscribe to our channel as we're going to be working more on this particular Docker Swarm project and looking at some of the upgrades that we can do with it, like maybe adding Seth or maybe even a PXE boot or something along those lines. But as always, for now, have a good night.